contribute around, India contributes around 30 to the percent of the budgets at the UN level. So the focus area of the ministry is the grid interactive and off-grid distributor. These are the focus areas of the ministries which are being actively pursued for development and deployment of renewable energy. The first one is the grid interactive and off-grid distributed renewable power. The second activity is the renewable energy for rural applications. I will be speaking in detail about these programs subsequently. Then renewable energy for urban, industrial and commercial applications. Under this program, we have a great emphasis on deployment of solar water heating systems in the country, and also it applies into municipal waste, industrial waste for harnessing energy. Then research, design and development in new renewable energy. There are some other support programs to facilitate implementation of programs and focus areas. This is the scenario of the Grid Interactive Renewable Power Program. Its aim is diversification of electricity mix in pursuance of the national goal of energy security, the generation of competitively priced renewable power. We have focused to reduce the cost of the renewable systems and increase the efficiency of the system. We have an aim to 20% share in power generation capacity addition from all sources during the 11th plant based on actuals of the 10th plant. Then we have 10% share, we are aiming at 10% share in electricity generation from power generating capacity addition from all sources during the 11th plant based on actual for the 10th plant. This is the table showing the achievement, grid interactive renewable power by the end of 10th plant and then 10th plant, 11th plant, and by the end of 11th plant, we from wind, it was 1,667 during 9th plant, and it was increased roughly 4 times during 10th plant, and 11th plant there is the aim for 10,500 megawatt capacity addition. Similarly, in the SHP, the major focus, as you can see, is on the wind sector and then biomass power. Key fiscal and financial incentives available to grid. I have already touched on these issues. We have 10-year income tax holiday on profits from sale of power, accelerated depreciation on wind and biopower capital costs 80% in the first year, nil concessional exercise duty on manufacture of renewable energy system devices, then concessional tariffs on for import of capital equipment, materials and components, subsidy for grid inductive biopower and small hydro power. These are the preferential tariffs range for wind, biomass and small hydropower for different states. The renewable energy for rural applications, the aim is facilitating affordable energy solutions in rural areas, lighting of all remote villages, hamlets by 2012, biogas from animal, poultry and human waste. Renewable energy for rural applications, up to the end of this gives the achievements made during 9th plant, 10th plant, and what we are aiming at during 11th plant, and by the end of 11th plant, what will be the scenario. Renewable energy for urban, industrial and commercial applications. This is a very upcoming program, and there is a major focus on this program because it will allow to utilize not only the solar for water heating, but also utilize the municipality waste, industrial waste for generating energy. Facilitating cost-effective and these are the aims. Facilitating cost-effective and affordable energy solutions in urban, industrial, commercial areas, conventional energy supplementation and fuel switching, biomass and solar thermal system devices, conversion of urban industrial waste to energy, energy efficient buildings. There is a lot of potential to save energy in building sector by incorporating solar passive features, and providing purchase access to RE system devices, Akshay Urja shops have already been created in the country. Renewable energy for urban, industrial and commercial applications. At a glance, this gives the trend of achievements in different areas under the program of urban, industrial and commercial applications, including water heating, drying, energy efficient buildings and cities, etc. 10th plant program power generation. This is the achievement made in different sectors during the 10th plant. 10th plant program demonstration activities in solar photovoltaics, SPV water pumps, SPV wind energy systems, solar thermal programs. You can see that the 10th plant physical target was 5.05 lakh square meters. And against this, we have the cumulative achievement is around 2.45 square meter collected area. 10th plan program, village electrification. Village electrification, this gives the achievements made under this program. Again, in the new technologies, R&D program, 10th plan program, other programs, 10th plan outlay, 10th plan funds availability, and 10th plan expenditure up to 31st 2005. Then the Indian Renewable Development Agency I've already talked about. Cumulative achievements as on 30th September 2008. Total installed capacity in the country from renewables is 13,450 megawatt of grid power, around 7% of total grid power installed capacity in the country. Electrification of 4,237 villages and 1,142 hamlets. 1 billion solar lighting systems have been deployed in the country, meeting lighting and pumping requirements. 2.45 million square meter collector areas have been installed in the country for meeting water heating and industrial heat application requirements. 4 billion family-sized biogas plants have been deployed till 30th September 2008. Estimated the medium-term potential. This is the scenario of our long-term perspective plan. Solar, we feel that around 5,000 megawatt potential exists in the country. And this is the area which we are giving top priority now, because we have recognized that solar is the most potential area for utilizing, for meeting the energy requirements in the country. This R&D thrust is going on in the development of photovoltaic cells, cost, high efficiency and lower cost solar cells. And then biomass area, we have the potential. Biomass total potential 78,000, woody biomass 52,000 megawatt, agricultural residues 16,000 megawatt, bagasse cogeneration, waste to energy 5,000 megawatt, biogas plant 12 million family-sized units, wind 45,000 megawatt, small hydro 15,000 megawatt. This is our aims. These are our aims, new and renewable aims. Grid interactive renewable power, around 10% grid power installed capacity through renewable power by 2012. With 5% electricity share and around 15% by 2032 with 10% electricity share. Alternate fuels, in alternate fuels, our aim is to substitute around 10% of oil by biofuels, synthetic fuels, and hydrogen in transport, portable and stationary applications by 2032. Renewable energy in urban areas, energy recovery from municipal waste in all cities, towns where suitable waste is available by 2022. Solar water heating system, 100% coverage of all institutional areas like hotels, hostels, hospitals, etc. by 2022. Renewable energy in industry. Energy recovery from industrial waste, 100% coverage of all potential industries by 2022. Solar water heating system, 100% coverage of all potential industries by 2032. Cogeneration, 100% coverage of sugar and other biomass-based industry capable of developing bankable projects by 2012. Renewable energy in rural areas, provision of electricity, lighting in around 10,000 remote unelectrified census villages apart from remote hamlets of electricity census, electrified census villages by 2009 and 2012. Augmentation of cooking, during this period, 2009 to 2012, augmentation of cooking, lighting and motive power through renewable energy in electrified villages by 2032. Now the research and development, where our ministry has given special focus now on the research and development activities so as to develop cost-effective and efficient technologies, advanced technologies in the country. And the focus of R&D activities, the cycle of R&D is as follows. The research to take up research and development projects, then design the system, develop the system, fabricate prototype systems, test its performance, then demonstrate it for its commercial potential. Then human resource development, we have to train manpower so as to maintain, operate the system. Then look for commercialization of the system, involve industry for manufacturing, and then take feedback from the field for further innovation. These are the aims of our R&D activities. Take up projects on research, design, development and demonstration to indigenously manufacture cost-competitive NRE systems, devices, strengthening the expertise of the R&D institutions in specific area for taking up advanced research for technology development and deployment by providing core support. Increasing share of indigenously designed, developed and manufactured NRE systems, devices. Increasing indigenization levels of NRE systems, devices manufactured, produced under foreign license agreements, making NRE industry competitive. Utilizing international cooperation frameworks for taking up joint research, design, development, demonstration and manufacture of advanced, new and renewable energy systems, devices. What are the tasks? These are our tasks. Increase efficiency to cost ratio of solar photovoltaic cells with the eventual aim of making grid interactive SPV power cost competitive. Make grid interactive solar thermal power cost competitive. We do not have much experience on solar thermal power in the country. Only one or two demonstration projects of 50 kilowatt capacity have been installed in the country, and we have very limited experience on the grid interactive solar thermal power. So what we are trying to do is to go for parabolic technologies, central tower receiver systems, parabolic fields installing the kind of configurations so as to generate power from solar concentrators. Active R&D activities are being pursued in this area. Megawatt scale wind electric generation. It has three committees for considering projects of different budgetary requirements and nature. These are the three committees. The first one, there is some tapping error. It should be RD&D project sectoral project appraisal committee, which is RDSPAC. So this committee, considers or recommends projects up to 1 crore budget. Then second one is RDPAC, it is for more than 1 crore budget projects. And then there is a technology demonstration project appraisal committee. R&D achievements in the country in these areas, we have made significant achievements: battery operated vehicles, fuel cell development, fuel cell battery hybrid vehicles, hydrogen powered motorcycles, up to 750 kilowatt biomass gasification systems. And we are trying to go at high capacity gasifier systems, up to 105 bar boiler for optimum bagasse generations, biogas system, solar flat collector system. In solar flat collectors, we have been able to develop test methods and standards of solar concentrating systems, solar passive architecture, single crystalline solar cells, amorphous silicon solar cells, up to 200 kilowatt wind electric generators indigenously, and small hydropower system. This is international cooperation. For last 3 or 4 years, we have been actively pursuing international cooperation for taking up joint R&D, because we have not achieved any significant breakthrough by interacting with the developed countries, because technology transfer was a very complex process which has not taken place so far. So for last 3 or 4 years, we have been trying to join hands together. The two institutions, R&D institutions in our country, and the same in the developed countries. So this is our focus of the international cooperation: joint research, design, development, demonstration, and manufacture of new and renewable energy system devices by R&D institutions, industries of both countries. These are the cooperation frameworks. Indo-US Energy Dialogue. We are actively interacting with US side for taking up joint R&D activities. Then we have also established sometime in 2005 India-Japan Energy Dialogue. There is a working group which coordinates the cooperation activities between the two countries. Then we have MOU signed with a number of countries: Italy, Iceland, the Netherlands, Thailand, Philippines, and Mauritius, and I think 3 or 4 more countries which I forgot to include in this slide. Then we have multilateral cooperation frameworks: Indo-Brazil, South Africa, IPSA dialogue is going on. Then EAPP, CDC, Asia Pacific Partnership on clean development, Asia Pacific Partnership on clean development, CDC, something like that. And then India EU Energy Panel, We have been interacting with the EU countries under this India EU Energy Panel, which is coordinated by the Ministry of External Affairs. But there are some barriers also, barriers and constraints in promotion of renewable energy. Inherent intermittent nature of renewable energy sources, leading to relatively lower capacity utilization factors. A relatively high capital cost when compared to conventional power systems. A requirement of preferential tariffs apart from other fiscal and financial concessions to make grid interactive renewable power commercially competitive propositions. And that's all.
Now I invite Dr. Naresh Kumar Sharma from University of Hyderabad for his presentation.
After two presentations, which are something very tangible to offer, very concrete, it may come as a very different kind of thing. Because basically I think I will be presenting some theoretical arguments. But I must thank Professor Mishra to drag me here because I was not sure that I will be able to reflect enough, put forward this theoretical argument. But I am thankful to him because he has made me start thinking about this. And he says that in the due course he can develop something on that. Tentatively what I have thought consumption issues in energy security. So I will say something about that because since he asked me that I must be here, Professor Mishra, I started looking at internet and various ways of what kind of things going on, and something that I didn't find there. So a lot of data and so on and so forth are there. I may mention that just a couple of words about my background, so that theoretical argument can be placed in the context of that also. By education, I have engineering background, but I am in profession of economics. So some things I take for granted as an economist. For example, efficiency arguments, proper resource allocation, and so on and so forth. So one way of looking at this thing is that once you have decided that you want this kind of thing, so much of energy is required for a certain kind of living, then of course it must be done efficiently with proper allocation between different resources and so on and so forth. And since we live in a system which is based on market principles in some sense, then that also decides that in which way these things should be allocated. I was having a look at this Parliament committee thing, although they do admit some use of subsidy. Basic argument there also remains that it should be through tariffs and so on and so forth. So that is one side, and that is where I say that we have something very concrete, tangible, that we have to do this and we need this for our living, and so how much of renewable energy sources, how much of non-renewable energy sources, so and so forth. Which way do we look at the requirement of energy? My basic argument will be that if we accept market principle, then fundamentally energy security in the sense of energy available in plenty for the things that we value will be available. That is an impossibility. So if you like, you can call it an impossibility. This argument, that is an impossibility because I think we all recognize that the market principle is based on the principle of scarcity, not on principle of plenty. And basic argument there being that it is the individuals who decide. And individuals, it is also seen that there is no limit to what they want. But if we talk in, I just reflect on some of the important studies that have questioned where we are going. To my mind, one important work comes is Nishan's work on economic and cost of economic growth. Even the very well-known Club of Rome study and so on and so forth. Their basic argument at some level is energy argument. That some way or the other along this path will run out of the available energy. degradation and so on and so forth. However, if we come back to argument about energy security in the sense of availability of sufficient energy for the things that you value, then you must also come to grips with the issue of what are the things that you value. In the absence of that, talking about energy security will have one kind of orientation on it. It will be having basically production bias and demand projections, which is what we have. In what we can make production possible, technological solutions, economic solutions, and in what way demand is going to change as a particular economic growth takes place, particular economic development takes place. So it will be basically around that. Okay. Now, if we talk about energy security as having enough energy for things you value, then you must come back what are the things you value. Things, as Aman Sen talked about, that various freedoms, freedom to move, freedom to perform certain actions, freedom to be healthy, and so on and so forth, or happy for that matter. If we talk in those broader categories, larger terms, okay, then also we have to see that what are the things that give this kind of freedoms, whether they are delimited by something or not. And that is where I bring these consumption issues. As I was saying that given any finite amount of resources is at the theoretical level, so long as they are finite. And if all individuals decide according to their own desire that how much they will want to consume a variety of things, then economics as it has evolved, it will remain a science of scarcity. Because there is never enough, so long as it is finite. You require infinite amounts to have plenty. And this is for that reason that we always be running short of energy supply, except in the temporary periods. Temporary periods will happen because energy creation is a lumpy thing. So it is possible that at some points of time, in some episodes, you have more capacity than temporarily what you can use. So other than temporary, you will never going to have plenty of energy, which is impossible apart from temporary reason. The way I see consumption issues coming is that I have looked at information which tells about that how much goes to agriculture, how much goes to industry, how much goes to transportation, so on and so forth. Okay? Composition of sources of energy also. But in what way it is used in these individual sectors, that kind of information is not available because I think it has not been tried. That we try to study that kind of thing. I will talk about India neither NSS level nor at central electricity authority data, anything is available. Since any of the sources that we have looked at, we do not find any data about that in what way this is used. Okay. I find that in the later times, it is a residential energy requirements, they are much larger compared to industrial or agriculture and so on and so forth. Now they obviously relate to what kind of lifestyles we have got. We cannot keep it unrelated to the kind of lifestyle we have. If we are going to have our urban living spaces, basically which are high-rise kind of things, they are energy intensive. Okay. So whether we want energy intensive lifestyles or which have less requirement energy, those kind of lifestyles, that is very important here. In general, energy security we see in terms of production, and on consumption side, what are the kind of issues that are addressed? We must have more efficient devices. It is not about that there is any way of limiting our requirement of energy per se. They are two very different kind of issues. That is what I would like to submit here. One is saying that we want all these things, but can you do it better? Okay. The second thing is that do we want all these things? So these are two different kind of issues. That let us have the more efficient light bulbs, more efficient cooling devices, and so on and so forth. Okay. Now, of course, economics will tell that we should do anyway. After doing that also, is it possible that we will have enough energy? By contention, we will not have enough energy even after doing that. So our requirement will keep pace with that. Okay. We are going to need that. See, life says there is no limit to that unless at value level we are going to change that. I'll just give one concrete example there. That if we are having our economic units organized around the local units, and then they have linkage with each other, as opposed to very large units where everything is seen to be essentially internal. Okay, you do not know what is coming from there. Then if we talk in terms of what economists say, final goods and intermediate goods. In the first, the component of intermediate goods will be very small, and final goods in the total production if any point of time you take. The second will be much larger. That means that you have to do a lot of things in the roundabout way before you reach the final destination. So, in this entire process, we will have accounting problems also. In macroeconomics, when I find out accounting problem for that. There are a lot of things which are intermediate nature, they get counted as final goods. Actually, before this seminar, we are having some informal discussion. Some similar point came here also. One of the scholars here was talking about. And we may have an exaggerated notion of that what final goods we are producing in the process. That kind of thing is also possible. So, in which way we organize our production and consumption systems becomes extremely important. Do we organize around the basically, I can put it, say local market, and then we have the interlinkage of that. What Manzani would have called oceanic circulation. You have waves upon waves, but they interact with each other. There is not a vertical structure, but you have a much larger horizontal structure. My suggestion would be that the demands on energy inherently will be much smaller in that kind of structure, and this will lead to a much more energy secure future than having very large economic structures. Okay, so we must probably, I can only say because there are no studies on that direction, but we must probably have some studies to see that in what way we are actually making use of the energy that is being actually generated, apart from efficiency of devices and so on. So forth. That in what way they go towards the final use for the things that we value, and to what extent goes towards intermediate points. Okay. Transportation is one example. Transportation is not needed in itself, but it facilitates certainty. We value those things. There is no doubt. So it should not be taken to mean that I am saying that you confine to small units themselves. Okay. So then if you take system as a whole, what is the best for that system? So as an economist, we always talk about best, because economics is nothing but optimization. Modern economy. But for system as a whole, what is the best? That is what I think we need to redo. Okay? Let me give an example from a very different field. That I was seeing one documentary some maybe 15 years ago. It was about milk. And it showed a map of India and saying that now milk can move from any corner of the country to any other corner of the country. And of course, we have a concept of fresh milk, which is very different from the concept of fresh milk that people had till very recently. You do not know how very old the milk, fresh milk is. Now, the documentary was saying, of course, it is a great achievement that you can reach anywhere. But just imagine that milk is traveling all over the country. It is being mixed together, it is being pulled together, and then it is being distributed. Okay. Is that the best system, or first having that you have at the local level, and then you also interlink where these kind of requirements are there, overall economic organization. And I think it deserves merit that we look at the local distribution structures and then see whether they are less demanding of energy, okay, and for the system as a whole. And this is likely to lead to greater energy security. But it's an open question. I am saying that unless the study is, I cannot make a claim about that. So it is deserving of study that whether we should move towards that direction, and in what way energy requirements and energy production also will take place. I just say one more thing and then I will stop that. In a lot of literature we see about the shifting from one kind of resource to another. We have here also about the biomass sources, that how much is from that and so on and so forth. When I was looking at data, it said about India that almost 27 to 30% of primary energy comes from wood. And we also see that many of expert committee reports, they talk about that many of the practices, traditional energy creation practices are inefficient and they should be replaced by more clean energy sources, more efficient energy sources and so on. This is based in an understanding of physical processes. Some people have been called about that the second law of thermodynamics, which mandates that something is more efficient than another thing. It should be relooked. There have been propositions that the kind of process it is talking about is high gradient processes. And high gradient processes seem to be more efficient. Anybody who is from that background will know that from second law of thermodynamics, the efficiency is between the source temperature and sink temperature. The greater the difference, more efficient is energy conversion. Conversion of energy, heat into work and so on. That's why you have the giant size thermal power plant and so on. But look at the processes of nature. They always take care of the ambient temperatures. And the amount of work they do is enormous. I think the Russian scholars also are talking about is that how much of the potential is there. Should be viewed in those terms. So, if we set the criteria which is not absolutely above board, you might get 40 minutes. That is what I was saying. One of the scientists in this area, C.V. Seshadri, he used to talk about that if you bring live systems into the picture, then these